Hello, everyone. I'm super excited to be presenting AutoScaling in Amazon DynamoDB to all of you. Um, I am a principal product manager in the DynamoDB team in Amazon Web Services. I have been working in the database field for a while now, and we have exciting things happening in DynamoDB, and AutoScaling is a recent launch that we had, and I'm really happy to be sharing the details with you in this webinar today. So here's a quick agenda of topics that we'll cover today. I know some of you might not be familiar with DynamoDB, so we'll just do a quick lap around DynamoDB at a high level, and then go into a scalability pillar of DynamoDB, and where autoscaling plays a very critical part. So specifically on autoscaling, I provide in terms of what is the key value proposition or value that you derive from it. And we'll look at how you experience that from the DynamoDB console, as well as control it programmatically. And finally, we'll close with how autoscaling works under the cover and how it's been implemented, something for you to know as a best practice. And then the key tips and tricks in getting the most out of autoscaling as you think about leveraging the feature for your applications. So let's look into DynamoDB at a high level now. So Amazon DynamoDB is essentially a NoSQL key value document database service. It is fully managed. We'll get to that in a second, what it means. But essentially the value of DynamoDB is that you can provision a single table, a NoSQL a key value store, where you do not have to think about the schema or the data type upfront. You create a table, add items and attributes to it, and you can scale the table to hundreds of terabytes of data. Now, as your table volume grows, you can send reads and writes to that database as you would, and you are guaranteed to get single-digit millisecond response time with DynamoDB, and with the recently announced DynamoDB Accelerator, which is an in-memory cache that is fully compatible with DynamoDB, your response times is guaranteed to be in microseconds. So essentially, it offers an unlimited scale for you in terms of storage, while still guaranteeing you with millisecond or microsecond response times. That's essentially the value of DynamoDB. And the combination of the fully managed and the unlimited storage and performance that it offers makes DynamoDB a very compelling offering for a certain set of use case scenarios, which I'll cover in a bit as well. As you would expect with any Amazon Web Service, DynamoDB is built with intrinsic fault tolerance, and it's designed to be highly available. So when you provision a table in a given region in DynamoDB, the data is automatically replicated across two other availability zones to make sure that your application is already always available, and DynamoDB is responding to all requests that you send. And DynamoDB integrates natively with many AWS services right from the box in terms of CloudTrail for logging, CloudWatch for monitoring, Elasticsearch for full text query support, and so forth. And the list is only growing as AWS releases more services. DynamoDB will continue to leverage all of those natively so that you as an application developer just focus on your applications, whereas DynamoDB continues to offer the full power of both the database service as well as the power of the AWS platform. Last, but probably the most important one with DynamoDB is you just pay for what you provision. There isn't any upfront commitment unless you want to with a reserve capacity model where you know that you are going to be using at a sustained level. Then you can sign up for a 1 year or a 3-year reserve capacity model, which will give you significant discounts. But you do not have to. You can just provision as often as you like in terms of the capacity that you need. And the bill meter runs hourly, so you purely pay for what you provision. As you will see with auto scaling, even that provisioning of that throughput capacity is not something that you will have to think about, which was the case until auto scaling was released. So moving on, here is a quick journey over the years of how DynamoDB came about and where we are today. Uh, Amazon.com, in its busiest time of the year in December in 2004, had a multi-hour outage where it could not process any more customer orders. You could imagine in terms of the huge amount of customer dissatisfaction as well as the downside in the business that we experienced because of that. So when something like this happens, you go look into the root cause analysis of that across from a process standpoint and a technology limitation standpoint. And one of the findings of that internal investigation was essentially we were running the limits of the relational database that we are using at that time. And as you might all know, relational databases on premises are built for scale up, data model, where as your data volume grows, you basically add more compute and memory to it, but it wasn't necessarily designed for scale out. And it also comes with a lot of upfront planning in terms of your schema, in terms of the relationship between tables and so forth. So as much as relational database have their value for certain types of data set, in wanting the millisecond response times as you would want in an Amazon.com shopping cart, regardless of how many customers are logged into Amazon at that time and submitting their orders, we quickly realized that the existing technology stack that Amazon.com was relying on was no longer, serving our specific purpose. So from that investigation came the Dynamo paper, which was a seminal work in terms of looking into the core ingredients of what makes a database and in terms of reliability, performance, and scale, and so forth. So from that paper came actually many NoSQL vendors that you might be familiar with today in the market. Dynamo was the name of the paper at that time, and the DynamoDB as a service from Amazon itself came about in January 2012. So we just celebrated, I guess, our 5-year anniversary of being, a publicly available service. Since then, now DynamoDB is a leader in the Gartner Magic Quadrant as well as Forrester Waves and many other analyst reports coverage. It's a leading cloud provider of a fully managed NoSQL database service. And today, it is available in all 16 public regions of AWS. And we have millions of customers tables, and several of them are north of 100 terabytes. So these are single tables which have data amounting to hundreds of terabytes, and many of them have tens of petabytes of data and still growing. And we are processing trillions of requests per month, and we are inching there even on a daily basis. DynamoDB is as much as our customers entrust us with their mission critical applications, it also is the database service that powers pretty much all of Amazon. Right from the retail site that inspired the creation of DynamoDB to all the recent services, whether it is Amazon Instant Video or the Kindle readers, the Prime program, all of AWS as you would expect, as well as the Echo devices, all rely on Amazon DynamoDB for different purposes for the very promise that DynamoDB offers. So moving on from the journey to talk about this fully managed aspect that I referred to earlier as one of the key selling points or value that you derive from DynamoDB. Now, if you look at how our databases, specifically the relational databases, market has evolved over the years, you procured a number of licenses from a vendor. You stood it up in your internal corporate IT data center where you dedicated real estate to it. You had racks of servers, and you manage everything on your own, right from the powering to procuring the hardware, getting the network routers, getting them allocated for all your mission critical applications, ensuring that you have fault tolerance and automatic failover, and you would do that all the way from your operating system up the stack to your applications. The as much as you get full control out of that, it's essentially extremely expensive and as well as time consuming. That's where the power of cloud and AWS comes in, where you don't have to do all of that, which takes us to where you could host a database that you procure from a vendor, but host it in an Amazon EC2 instance, where you don't have to worry about the racks of servers that you need to procure, the hardware or the OS installation and so forth. You just spin up an EC2 instance with one of your favorite relational database, and off you go, and you can start building on top of it. Except what happens if your OS vendor releases a new patch, or the database vendor releases a new feature or a new feature pack that you want to leverage, then you'll have to again install that, ensure that your application is available while you're patching it and while you're doing the upgrade. Again, you are still having to dedicate resources, time, at the same time ensure your application is available, even though you are leveraging the power of cloud with the EC2 instance. That brings us to DynamoDB, where all you need is manage your application, create and develop your application. Everything else is fully managed for you. So you don't think in terms of database, particular vendor. You don't think in terms of a particular, version. You don't think in terms of the feature set that is released, but is your application is not leveraging. You don't have to worry about availability or scale or performance. All of that promise comes in right out of the box. So you just come into the console, as we would see shortly, create a table, and off you go. After that, you can either modify the settings of that right from the console, or you can do that all programmatically using our CLI and SDK. Now, combine the power of the NoSQL, which is a non-relational database, which is inherently built for scale out, which is exactly the design point for the cloud paradigm as well. And you combine the two, what you get is essentially a service that you don't have to worry about. Amazon takes care of for you, and your application can go from day one having very few users, serving very few requests, to serving millions of customers across the world, dealing with trillions of requests, and all of that is managed for you. You just need to worry about the application in terms of features and how it scales to meet your customer demand. And combine that with the pay-as-you-go model. You exactly pay only for what you provision. So you can scale as your business grows, as your customer acquisition grows. What you pay for DynamoDB grows along with that, without having to have any kind of upfront commitment. So now let's take a look at how do we think about DynamoDB as a service internally from Amazon, as well as from your customer perspective, as you would expect to entrust your critical data on DynamoDB. What are all the channels or levers that you want to make sure that we are meeting your demands for? So, as you would do today for any mission critical database on the on-prem, or whether you're hosting it yourself, we think about DynamoDB investment from along the same lines, where scalability is super important. Our customer scale needs in terms of both storage and throughput is only growing by the day, and so we'll continue to invest in that. And AutoScaling is a key example of it, which we would talk about in a little while. Performance. So no matter how much we scale, and no matter which region that you create your table in, we would guarantee that you get the single-digit millisecond response time, and with DAX, the microsecond response times. So we will continue to offer on that promise, no matter how many features we add and how much scale of data the customer is taking the database table to. Security is very important in general, and definitely for your data. So our feature set definitely focuses on security and monitoring. Again, just because you have interested with Amazon for all your database management needs doesn't mean that you do not get the right set of controls and knobs to ensure that only the folks who critically need to see the data are able to see and only have the right set of permissions. So by integrating with IAM, again, a key example of where we are leveraging the AWS platform, we are able to ensure that you have item level and attribute level policy controls for any DynamoDB table. Availability and data protection. This is an area that we have always taken seriously from the 3AZ replication that I talked about, as well as our current and future roadmap is going to be heavily invested in this to ensure that, again, the mission critical applications stay available, and then customers have business continuity and data protection built into the service from the get-go. Manageability is an aspect where, as you have more number of tables and you have them across multiple regions, you want to be able to have a handle on ensuring that you have the right set of visibility and you're able to manage at scale. So there are, again, features that we have leveraging the AWS services to ensure that we are providing the right set of visibility to you for ensuring that your database are manageable. TCO is the core of the promise. Again, like I said, because it's being fully managed, we are saving customers a lot of money. And as we introduce new features, we are going to look at it broadly and ensure that the TCO remains low for our customers. And we expose a set of APIs for DynamoDB, and as do all the other AWS services. And in combination of them, essentially, you can have an application running on AWS that leverages DynamoDB as part of your ecosystem. And we have our DynamoDB local, which is a downloadable copy of DynamoDB that you can develop natively using Visual Studio or Eclipse, and then push it out to DynamoDB service to go into production. That's just an example of a key offering and a tool integration that we have done to make sure that the developer experience for DynamoDB is also very smooth. So looking into the feature set across all these different pillars that we just talked about, and going into level deeper. So many of these are features that for folks who are familiar with DynamoDB that you would quickly recognize. So I'll touch upon the things that are one, recent, and two are very important for our customers. So talking about specifically performance, as I mentioned, the DynamoDB Accelerator is the in-memory cache that is fully compatible DynamoDB that we released recently, where you go provision clusters of nodes that essentially pulls in data based on the frequency of access and has it in the local cache. And what that does is essentially the amount of time that you and the read units that you consume in your DynamoDB is reduced. You're going into cache, and if it's a write, it's essentially the cache passes it through to backend DynamoDB to ensure that the cache is consistent always with the backend data and the schema. From a security standpoint, I covered the IAM policies where you can restrict control specifically in terms of items and attributes. We are also fully compliant, and the list only grows. And we are, along with all the most of the one that you see there, the DoD IL4 is the one as the latest compliance that we achieved in so a few months ago. VPC endpoints is something that we released yesterday, where as with EC2 and RDS and other major services of AWS that are now have VPC endpoint support, DynamoDB joins the list, where you no longer have to access the DynamoDB endpoints through the public endpoints, which are susceptible to attacks and do not have privacy. Now you could access DynamoDB through VPC endpoints. That ensures that one, your performance is improved, not having to go through public routers, as well as it's private. And these endpoints as well, you can restrict access to them further using IAM users and roles. Moving to the manageability and TCO, I'll talk about time to live, which was a very commonly asked feature of DynamoDB that again was released earlier this year. What it is at an item level, you could set an expiry date in epoch format in DynamoDB, and a sweeper on the DynamoDB service will automatically go and inspect those items, and past an expiry date will purge the data for you. So it helps you to limit the growth of your table size. It simplifies your application. And third, you're paying lesser for storage because you are purging data that you don't need. Now, at the same time, you might want to have a history of those changes or archive those deleted data, which is recorded in DynamoDB streams, which is essentially a log of the past 24 hours activities that happened in a particular table. So you can look at the data that is deleted or getting purged, and you could selectively have them backed up to S3 with integration with AWS Lambda service. On the dev platforms and tools, as I had mentioned earlier, we integrate with all the leading AWS services as it makes sense from an application developer standpoint. The one that recent one that I would mention is the last one, which is the DMS connector, which does native out-of-box migration from MongoDB to DynamoDB, which means that you can have your existing application that you have built. You can migrate the data to DynamoDB using the DMS connector. This was released again a couple of months ago, and that is something that is very positively received by customers. So let me quickly touch upon the key scenarios that customers use DynamoDB today for, and then switch into AutoScaling. So these are different segments and verticals that customers use DynamoDB for. If you take ad tech, where you have multiple vendors bidding for a particular ad of this place, in several internet advertising platforms, you'll need to basically win those bids in a short amount of time, in a matter of milliseconds. So they tend to leverage DynamoDB for those. Think of gaming, we have customers who release games where you would not be able to foresee whether you are going to have, say, thousands of new users or existing users who are going to leverage the game, or you're going to have millions. So DynamoDB is a great example of that, where you can store the user profile as well as the game points, the leaderboards in DynamoDB, without having to worry about whether that data is going to be small or large, but at the same time ensuring that you are having that real-time response times of those leaderboards as the games are in progress. IoT is a key streaming scenario where as devices are getting smarter and they are streaming back information, whether they are trucks or thermostats or what have you, those data are getting streamed back into cloud providers for analytical purposes. Either you could, depending on the volume of data, directly stream that and write it to DynamoDB, or you can leverage the AWS Kinesis services to both means, as well as streamline in terms of what you write into DynamoDB. So that's just a few examples of verticals that are using DynamoDB in interesting ways while leveraging essentially that infinite scale at a guaranteed performance. So let's now switch into AutoScaling, which, as I mentioned, is a key investment that we made to ensure that we are meeting the scalability investment pillar for DynamoDB. So until AutoScaling was released in June, what you had to do as a customer was you came into the console, you say create a table, and then we would ask you to either guess the number of throughput capacity you would need in terms of reads and writes, or you would go with default settings, which was 5 reads and 5 writes. Now, application demands, as we know, never stays the same. They are dynamic and are seasonal. In those scenarios, what you had to do is go back to the console or call the update table API of DynamoDB to increase the provisioning of the reads and writes. Now, what happens if you guess wrong? If you over provision, then you pay excess capacity that you don't need. On the other hand, when you are under provision, your application gets throttled and it suffers in terms of availability. So that's where auto scaling comes into the picture, where in terms of the feature, like I said, you do not have to think about in terms of reads and writes capacity for whether it's tables or global secondary indexes, which is supported natively in DynamoDB. All you need to think about is in terms of what is the utilization percentage that you want, which is simply the consume capacity over provision capacity. So as your application sends in more requests and the consume capacity increases, we will monitor what if the utilization is dropping. If it is dropping, then we would essentially drop your provision capacity as well. And as your utilization is increasing, we'll increase that to make sure that the capacity is always stays in sync with the application demands. You as a customer can always say, hey, do not scale it down below a certain limit, or do not scale it up beyond a maximum limit, for ensuring either availability on the downside or ensuring that you are not having to go past your budget. So that's something that you can set right from the console. Along with the console support, you also have programmatic access. We'll see that in a little while, where you can control that from the command line interface and SDK, which are exposed in terms of GSIs. Customers who already have tables can leverage auto scaling as well. They can just go and turn it on, and it works right away. In your manual provision capacity up until that time is disabled, and auto scaling settings kicks off. You can also enable it for a while and disable it depending on your need, whether you want to actively monitor and control yourself versus auto scaling take care of the throughput management for you. And you get full visibility of the scaling activities right from the console. So you'll see the timestamp, you will see whether it's a scale up or scale down activity, and whether the particular scaling activity was a success or a failure. The power of the auto scaling is that it is actually internally for Amazon. It's a central technology team that powers the scaling technology for multiple AWS services, including EC2, ECS, EMR, and others. So what are the benefits of auto scaling? Like I said, you don't have to do any guesswork anymore. And you do not have to keep actively monitoring your consume capacity and keep adjusting manually. You just focus on building your application. Auto scaling is going to automatically accelerate and decelerate. And if the pace at which it is doing, as well as if the utilization that you're getting is not meeting your demands, you can change that at any time. There is no limit to it. And auto scaling comes built into the platform, and there is no additional cost beyond what you pay for the DynamoDB throughput. So let's look at what the experience looks like in the console. So for people who are using DynamoDB, this should be really familiar. So you go into the AWS Management Console, you select DynamoDB, and you land here in the screen. And all you need to do is say, click on Create Table, and that takes you to this screen here, which simply asks for your table name and the primary key that you would have, as well as optionally you can add a separate sort or range key, but it's not required. And then you can just click Create. You don't have to think about any other settings. What you see here with auto scaling is that it used to be that we provisioned the capacity as 5 reads and 5 writes manually in the past. Now that has been replaced with auto scaling. So going forward, when you create a new table in DynamoDB, it is auto scale enabled by default. So yet another thing that you don't have to think about for your database. Now, say if you had to uncheck the default settings checkbox, then what you would see is this, where you have the option of either doing the provision capacity manually as before, or you do auto scaling. And as I said, auto scaling is the default. So you see the provision capacity disabled in the screen here, and auto scaling is turned on for both read and write with a certain set of default settings. That's 70% for utilization and minimum and maximum in terms of what is allowed for your account. So you click create and off you go. Now your table is autoscale enabled. Once the table is active and it is autoscale enabled, you can always come to this capacity tab, which is what you see here, and you can change the settings here at any point in time. What this screen is showing here is once you have autoscaling running and managing the throughput for your table, you can see the ongoing activity that is going on in terms of when a particular scaling activity was triggered and when it ended, and what is the, whether it's a table or a global secondary index that is being scaled, and whether the unit that is being scaled is for read request or write, as well as what is the scale up or scale down actual number of the throughput capacity that auto scaling triggered. You can also monitor these changes in the graph under the alarms under metrics tab under CloudWatch monitoring. What you see here is as the consumed spiked for this particular workload, auto scaling essentially adjusted it, and as it dropped, auto scaling is also reducing the provision capacity. We are actively working on ensuring that the response times of both scale up and scale down are minimized from the actual consumed capacity. So to ensure that as your demand scale up, we scale up to for meeting your application, as well as we scale down very quickly so that you're not paying any excess in your bill. These are the set of API actions that are available as part of the application auto scaling, which, as I mentioned, powers many targets, including DynamoDB. So for a given account, you can register a particular table or GSI as a scalable target with the application auto scaling platform. And then you have the put and delete, as you would expect. With the put, you create as well as update an existing policy with new set of settings, and you can enumerate through all the policies with the scaling policy, describe scaling policy it's called, as well as all the tables and GSIs that you have registered as a target with a describe scalable target. And scaling activity gives you the historical information of all activities that was done for a particular table or a GSI over the past 6 weeks. So let's quickly look at how auto scaling actually works. This is purely for, I guess, for your information. This is all happening under the hood, and there isn't any thing that is expected from the customer to manage here. Auto scaling essentially leverages the CloudWatch metrics and alarms of AWS. So step one, when the user creates an auto scaling policy, either from the console that we just looked at, or by registering a target and creating a policy through the APIs, a set of CloudWatch metrics and alarms are created on behalf of the customer on the scaling policy. And these metrics are vended to CloudWatch every minute. And when there is a breach, which right now is about 5 minutes, and which we are looking to reduce further for scale up and say 15 minutes for scale down, we are going to essentially fire the alarm, which is going to call application auto scaling. That's a step 4 there. And application auto scaling essentially looks at the utilization percentage at that point in time, and depending on whether it is higher or lower than what was set by the customer, it is going to, on the behalf of the customer, call the update table API to DynamoDB with the right amount of capacity throughput units. Again, this is done automatically, dynamically, based on what is the right amount of throughput units that's needed to optimize between performance and saving on costs. Once that is done, the table has that amount of capacity set for the particular target, and the it is continuous, it's dynamic, so it happens every minute, and it is done in different number of times. The only limit that is there today is that customers should be aware of is the number of scale downs is limited today because of the load on the system to 9, which is 4 scalable dial downs at any point in the day, and 1 for every subsequent 4-hour window. Again, this is something that we are continuously going to work in improving as customers' demands in terms of both scale up, which is unlimited today, and scale down increase happens over time. So what are some of the best practices for auto scaling? Auto scaling today, given the number of breach times that is required to make sure that scaling works, is not ideal for workloads that have, say, a sawtooth pattern, or has sudden spike in a minute and then drops down quickly. The alarms are not going to fire in time for you to be able to handle those kind of traffic patterns. So auto-scaling is more ideal for where it is fairly predictable and changes gradually. And also, for a new table, we would recommend starting with the default settings and then tweak as you go in terms of both utilization, as well as in terms of what is the minimum capacity below which you don't want to scale down to, and the maximum capacity for which you don't want to scale up to. And as I said, there is a limitation in terms of the number of scale downs today. So optimize for that if you can, in terms of what you would want to do and the timing when you would want that to trigger. And lastly, make sure that you apply the same settings for your global secondary index as tables, because the throughput capacity are at the table level or the GSI level. By having the same settings, you ensure that your query against the GSI and as well as the table writes that you have to base table are fairly synchronous, so that your GSIs have the most up-to-date data for your responses. And if you can always enable and disable auto scaling if you have windows of time when your workload pattern changes programmatically. So definitely that's something that you should leverage if you have the need. So that brings us to the end of the webinar. So thank you all for attending the webinar today. I really appreciate your interest in DynamoDB and auto scaling. And at this point in time,